In this example, we have both a product, 4x times cosine, and we have a difference. So we have a subtraction and a multiplication problem. So what we're going to do is we're going to use the rules when we're adding and subtracting integrals. We can break them apart into two different integrals, so that's what we're going to do. And we're going to take the antiderivative, or the integral, of each individual function. So let's look at the very first one. I have a product, I have a function, which is cosine, and I have 4x as my term. So u is always going to be the number or the variables inside the function. So in this case, u is going to be 5x squared plus 2. So the derivative of u is going to be 10x dx. Divide, and I'm going to have 1 over 10x that's equal to dx. So I'm going to go ahead and take the antiderivative of the first one first. So the 4x is going to stay by itself, or it's going to come down. I'm going to have cosine, and instead of 5x squared plus 2, I'm going to have u. And I'm going to go ahead and multiply it by the dx. So notice that my x's are going to cancel, and then the 4's and the 10's, I can reduce them to 2 and 5. So my new integral is going to be 2/5 cosine u du. So when I take the antiderivative of cosine of u, because 2/5 is a constant, it's going to be sine of u. So it's going to be 2/5 sine of u, substitute u back, 5x squared plus 2. Okay. And usually we would add a plus c, but we need to do the second integral. So now I'm going to come back and do the second integral. So this is just a regular function. 7 is a constant. I'm going to bring it down. So for x squared, I'm going to go ahead and add 1. So that becomes 7x to the cube, divide by the new exponent. So I'm going to have 7/3 x cubed, and this is where I'm going to add the c.